Unit 4, Section 4.2, we're going to look at multiplication and division properties of exponents. And so again, our goal today is to use the multiplication property and be able to use the division property. This unit is something that definitely builds on our previous day. So you'll also see negative exponents, which anything to a negative means move it to either the bottom or the top and change the sign. And then zero exponent property says anything to the zero equals 1. All right, so let's look at first our multiplication. So if we wrote the expanded form as well as the simplified form of the following, so let's look at what this would be. X to the fifth, if I expanded it, would be x times x times x times x times x, times x to the 3 would be x times x times x. So right now I have 1, 2, 3, 4, 5, 6, 7, 8 x's. So if I simplified that, I could take x to the fifth times x to the third and get x to the eighth. All right, so let's see if we have a pattern here. Expanded version would take 8 squared is 8 times 8 times 8 to the fourth, which would be 8 times 8 times 8 times 8. So here's my expanded version where I have 1, 2, 3, 4, 5, 6 eighths being multiplied. So I could simplify that into 8 to the sixth. This is a pattern. The 6 is related to the exponents. How many 8s do I want in the end? 6. I had 2 and 4. If I add those together, it gets me my new exponent. 5 plus 3, if I have these exponents, gets me the x to the 8 here. That is our multiplication property of exponents. To multiply, use the product rule. Add the exponents. Keep the base. So if I add the exponents, if I have x to the a times x to the b, as long as they have the same base, I keep the base and I add those two values up top, a plus b. So if I wanted to simplify these, I have y to the 6 and y to the 1, so 6 plus 1, I would have 7 y's total that are being multiplied. 7 to the third times 7 to the second, I keep the base and I add those. I have 3 here, an additional 2 here, gives me 5 total that are being multiplied across. P to the 0 we know is 1, but if we do the rule, we would have, okay, this is 1 here. I can put in that exponent when it's by itself. 0 plus 1 plus 5. Really, I have 6 in the end because this is just times 1. Still gives me 6 here. In our expanded form, now we have a 4 here and an x times 6. So we would have the 4, and then I'd want 1, 2, 3, 4, 5, 6 times the 5 and the 1, 2, 3, 4 that I have for the second part. When I combine these to the simplified version, multiplication is commutative. So the order of this doesn't matter. So I can take the 5 with the 4, and I'm still doing that same operation. 5 times 4 gets me 20. And then how many x's do I want? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the multiplication for the numbers out front, the coefficients, 4 times 5 is 20. And then the exponents, we still keep the base, and 6 plus 4 gets me the 10. Similar idea here. Here I have a times a, and then I have b, 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 b for 4 b's, and 1, 2, 3, 4, 5 for the expanded form of a squared, b to the fourth, and a to the fifth. I can simplify this by taking all the a's together. How many do I have total? 1, 2, 3, 4, 5, 6, 7. And how many b's total? Same base. I still only have just 4, so there was nothing that I could combine with that b to the fourth. So I expanded it and then brought it back down to b to the fourth again. Multiplication, the order doesn't matter. So those a's can be combined even though I haven't done the b to the fourth yet. So if we look at our 4 examples here, did I misadd that? Okay, no. Whew. All right, so sorry, I had a brain fart there. So if we simplify, here we're going to multiply the numbers because coefficients out front multiply. And then these have the same base, so we can combine them. 4 and 3 makes I'm multiplying z 7 times. 24, z to the 7th. On number 2, I have 4 times 3, which is 12. I have c to the 3 here. Can't combine with that base, but I have one more here, one more c here to make 4, and then into the 5 comes down. And I can't combine anything else, so that's as simplified as I have here. Numbers here, I have a 5, so I can take my 5 here. Z to the 4th, okay, so I have that base here. 4, and then I have a minus 3, so 4 plus a negative 3 is just 1. And then nothing combines with that y. So even though I started with a negative, it became positive when I did 4 plus a negative 3. On number 4, 4 times my other number is 2. And then I have a here. Okay, so I have 1, 2, 3, and 4 more here, so I want 7 total. Then I have base b, 0 here, which is why it would be 1, but 3 here, so I'll bring that over. And c just comes down. I don't have anything that can go with it. So as I simplify these, it's as far as I can go when everything has one base, so there's no other z's, there's no other c's or n's, and everything's been combined as far as I can, using that multiplication rule to help me combine my bases that are the same. In a similar way, we can start looking at our division property. So if I wrote the expanded form as well here, now I would have 1, 2, 3, 4, 5, 6, 7, 8, divided by 1, 2, 3, 4, 5, 6 y's. So we've practiced that anything divided by itself cancels out and is 1. So here I would have 1's canceling out, another, until I get y left over with another y, making it y squared. In a similar way, I could cancel here, so I'd have 1, 2, 3, 4 3's on top in the numerator, and 1, 2, 3, 4, 5, 6, 7 on bottom. Anything divided by itself cancels out, so it's 1, leaving me with 1 over 3 to the 3rd. So this pattern might not be as obvious here, but if I look at the relationship between the powers here, that 8 here, 6 here, how did I end up with 2? I didn't add like I did with multiplication. Now I'm going to subtract. 8 minus 6 gives me 2. And so that one works out here, but what about this one? 4 minus 7, if I did that, I would get a negative 3. So if I had done this, this would be 3 to the negative 3. Okay, well, we talked about negative powers last time, which says move it and change the sign. So it does end up working with our division property that says top minus bottom, and if we have a negative exponent, still fix it because it stays in the bottom if it ends up negative. So that's our division rule that says our property of exponents will subtract powers, so top minus bottom, and keep the same base. So they have to have the same base to simplify. I can't combine x to the a and y to the b. That doesn't simplify. They have to have the same base. So here I keep the base the same and I subtract a minus b. Whatever that equals is how I apply the quotient rule or the property of exponents for division. So here, keep the base. 6 minus 2 is 4. And again, if I wanted to simplify that out, since it's just numbers, I could put that in my calculator, 4 to the 4th, and I get 256. But sometimes those numbers get quite large, and we might just leave it as the power 4 to the 4th. On number 2, we have w to the 7th divided by w to the 3rd. So I keep the base and subtract. 7 minus 3 is 4. Can't do anything with a power here, so I would leave it. X squared divided by x to the 1. subtract 2 minus 1, I get x to the 1, or I could leave it as just x. On number 4, keep the base. I have 4 squared divided by 4 to the 6th. 2 minus 6 is a negative 4. This goes back to what our lesson was before, where if we have a negative exponent, it's not simplified until I move it and change the sign. This is considered simplified, and again, I could write that as 1 over 256 if I wanted to. I would be okay if we left it here in the power. Number 5, we have x, same base, so now I have negative 4 minus 9. What is negative 4 top minus 9 on the bottom? I get negative 13. So just like we had here, it's not considered simplified if we have negative exponents. So we need to move that to the division and change the sign of our power. A negative exponent means repeated division here. And on 6, we have a divided by a to the negative 2. So we're going to take 1 minus a negative 2. So if I put that in my calculator, 1 minus negative 2 is positive 3. So a to the third can't be simplified, so that's as far as I would take it. Okay, there are properties that we can use, and there's not necessarily an order to them. So if you saw this negative exponent or this negative exponent and you were like, woof, I need to fix those first because that was the rule we talked about, this would move to the top and then become positive. And then we'd be back to now our multiplication rule that would say add the exponents. We would get the same answer. Same on this one. If I took x to the 4th and I moved it to the bottom with that x to the 9, now I have multiplication property says add these, x to the 13th is the same answer we got with our division property. So the nice thing is that you can do the properties out of order because there's not an order to the operations when the only operation we have here is multiply. But there is a way that we want to make sure that everything's combined that we can. No exponents that are negative or zeros. Those need to be simplified and continued. So our last couple examples here is bringing in those bringing in those coefficients as well as multiple variables together. So if I took 1, 2, 3, 4 x's with 2 y's and I divided by 1x and 1, 2, 3, 4, 5 y's, I can still simplify. X's don't simplify with y's, but they do simplify with themselves. X to the 3rd here, I have 3 x's left over. And then it's almost like a new problem here where I can cancel the y's with itself and I'm left with 4 y's on the bottom. And look at this if I use my division. 4 minus 1, that gets me my 3. 2 minus 5 gets me, oh boy, 1, 2, 3, 4, 5, 6. Whew, I counted too many here. This should not be 4 left over. This should be 3 left over. I apologize for my extra y I had there. Because 2 minus 5 is a negative 3, which means it moves to the division with a positive. And that's how many we have left over if I could actually count to 5. So I apologize. So our 2 examples that we have here, we have 5 to the 6th over 5 to the 6th. 6 minus 6, that's 0. So those are canceling each other out. 3 to the 4th over 3 squared, keep the base. 4 minus 2 would be 2, and we could simplify that one if we wanted to keep going. On this one, we have x, y, and z's with numbers to begin with. So the first thing I'm going to do is simplify that 4 over 12, and our calculator will do that for us using the fraction button. So if it simplifies, we can put 4 over 12 in and hit enter, and if it simplifies, we'll get the 1/3. If I tried to do 1 divided by 3 and simplify that, when I hit enter, it'll say, you're already done. It is 1/3. So I would simplify my fraction, and I would get 1 over 3, and then I would look at x's. Okay, so 2 minus 1 is 1, and then I would look at y's. 1 minus 4 is negative 3, and then I look at my z's. Negative 4 minus 3 is negative 7. All right, so I've used my division property that said top minus bottom for my exponents. But when I simplify here, I have negatives here that I need to make sure that they move so that it's completely simplified. So x will stay in the numerator, the 3 is still down here, but the y needs to move and change the power to the positive. The z needs to do the same thing as well, so that the z and the y move down to that repeated division because of their negative exponents. All right, so today we put a couple things together, still practicing our negative exponents and zero exponents, but now we've also introduced our multiplication and division properties. Let me know if you have questions on your practice, and have a good one.